The Wheatstone bridge is a type of circuit that's used to interface sensors and transducers into an electronic circuit. And the way that this is done is the configuration of the resistors that are going to orient this particular circuit, or whatever it is, and one of these becomes a variable resistance. As we look at this circuit, actually what it is it's two parallel resistor networks that are in parallel with each other. And I'm going to illustrate that shortly. If we take a look at these particular, what we call resistive arms, they actually have a ratio. R1 is to R2, as R3 is to R4. When the resistors are exactly equal with each other, there'll be an equal amount of current going through each one of these resistive branches, resulting in the exact same voltage that would be at this point and the exact same voltage as this one. And the subtraction of the two voltages should be 0. This indication device right here is called a galvanometer, It's a zero-centered milliamp meter, zero-centered microamp meter, very sensitive, and what it does is it detects any kind of a shift in the voltages that are appearing between A and B. And that's going to occur if there's something that's changing in one of these branch resistors so that it causes an off balance due to the difference in currents going through the two arms as opposed to the other one. And it's going to cause this meter to go maybe positive, or it might have it go in a negative direction. When they're exactly equal, you have 0 voltage, 0 microampere, 0 milliamp. Taking a look at this particular circuit then, what we need to do is take a look at any kind of values that we can put in here to cause us to be a sensor, like this. This is a variable resistor, and in between the 2 points, although it's similar to a rheostat, it's actually something that's going to react to any type of a physical stimuli. It could be a light sensor, it could be a temperature sensor, pressure sensor, and their outputs oftentimes work into circuits like this that match their internal resistance with that of the entire bridge. This could be an adjustment arm. We say we want to have a particular value of resistance at room temperature. So we would take this adjustment here, or we could put it in this arm and cause this to have a 0 output, and then as a shift occurs, say in temperature, it would cause this meter to either increase or decrease, that is, go towards minus or towards positive, and it could be calibrated in temperature. Taking a look at this particular circuit then, it's also used to measure a lot of unknown resistances. Sometimes they have two terminals coming out here to an unknown resistor. So we could take this and say it's R sub unknown. This one up here then, this becomes the variable, and it's a calibrated resistor. So whatever this unknown is here, if it's within the range of this circuit, R3, which is a variable resistor, would cause it to adjust back to the 0 point and allow it to go back to 0. That's called a null, and that indicates that this bridge is in balance again. Let's take a look at this particular circuit, and we're going to redraw this so that you can see its parallel aspects. Just as we did with the series parallel network, we do this with the bridge. And as we take a look at this, the exact same points still exist. Here's the A point. We're going to put a voltmeter, or it could be a milliamp meter in there. And so the ratio of these two arms with each other, if they're exactly equal, A minus B should result in a 0 voltage output or 0 current, depending upon how it is wired into the circuit. But as we're taking a look at these different values, if they're exactly the same, they'll have the same amount of current going through them, which means they'd have the same voltage at this point A as regard to point B. we could measure across this one, or this one, across here, or here. That means that if all the resistive values are the same, there's R1, R2, R3, and R4. So as we look at this, if all of those are exactly the same value, we're going to have a 0, we'll have a nulling on the meter, and that will indicate these are all in balance. Whenever that 0 occurs, there's no differential shift in the voltages between the 2 points. It winds up being 0, and these are in balance with each other. Again, if we want to use these for calibration, we can take this and turn this into unknown resistor here, or we could use this as a sensor or transducer in an industrial situation. And we could do this as a 0 adjust. Sometimes we use this, other times it might be here, to adjust these two for, again, the 0 balance at whatever this resistance is at this particular physical stimulus. They're also used in calibration of capacitor systems and any other types of components. I use the resistance because that's the most common application in the understanding on how this bridge works.